You must understand what types of application equipment are available and how to use them correctly in order to get effective pest control. Depending on your equipment, you'll select a pesticide formulation that can be efficiently applied. This requires that you understand basic equipment concepts and the major components of the equipment. Once you have selected the equipment, you need to understand the label directions regarding how to apply the product and how to calculate the amount of spray and product needed. Because most applications are made by spraying, we'll review some practices you can use to reduce spray drift. In the Directions for Use section of the label, it states what application methods can be used for the product. As you remember from the Federal Law module, it's legal to use a method that's not listed on the label, but manufacturers give instructions on the most common approaches. Let's look at some. Broadcast treatments can be made by aircraft, ground application equipment, and by boats. By broadcast, you fully cover a large area. Band treatments are common in agriculture when crops are grown in rows. You then band a treatment either over the crop row and skip the unplanted area, or treat between the crop rows without treating a crop. By using band treatments, you greatly reduce the amount of the product needed. Crack and crevice treatments are common when treating in and around buildings. Spot treatments are used to target a small area only. They are common for agriculture, landscapes, and rights-of-way applications. If sensitive species are in the area, it's often wise to use a very targeted approach to pesticide use, and spot spraying works well for this. Basal treatments are used for woody plant control. You simply apply to the lower portions of the tree or shrub and the exposed portions of the roots. Over time, the pesticide is absorbed. Tree or stem injection is a more direct method for getting pesticide into the vascular system of plants. When using injection, you typically use very concentrated amounts of product. Rope wick or wiper treatments rely on height differences between the crop and the weeds. For short crops and tall weeds, you can simply use equipment that wipes a herbicide across the tops of the tall weeds. This way, the herbicide does not come in contact with the shorter crop and control is achieved. The label also indicates where the product needs to be placed. Foliar applications are just that, applying the pesticide to foliage. Soil injection is used around structures for termite control and in agriculture for soil pests. Soil incorporation is a term that directs the applicator to use tillage, rainfall, or irrigation to move a recently applied surface application into the soil. The spray application equipment may be combined with tillage equipment for incorporation, or incorporation may be a separate process. If you recall, incorporation was important for products that could be lost through volatility or blowing dust. Incorporation is also used to target pests that live in the soil or to move the product into the root zone for plant uptake. There are some safety considerations related to application equipment and planning. Several types of safety systems are used to protect either the applicator or the environment. Let's look at three systems: closed mixed load systems, enclosed cabs, and pesticide containment pads. Closed mixing and loading systems prevent human contact with the pesticide. They are a great way to reduce human exposure and also reduce the need for personal protective equipment. In addition, they reduce the possibility for mixing errors by accurately measuring the pesticide and decreasing the chance of spills. There are two primary closed systems, either mechanical or water-soluble packets. Mechanical closed systems are available for many different equipment sizes, from backpacks to large volume rights-of-way or agricultural application equipment. A mechanical device removes pesticide from the product container using either suction or gravity and transfers it into the spray tank or directly into the spray line. It also allows for closed system rinsing and transfer of the container rinsate into the tank. Again, no human exposure. These systems are product specific, and when used with computer controls, the applicator can switch between several different products as they make their application. Many bulk tanks from 40 to 600 gallons also use a mechanical closed system to transfer material from the mini bulks to the sprayer. By using mini bulks, the container can be returned and refilled. Some distributors actually make custom mixes to meet your specific needs. Another closed system is the easy-to-use water-soluble packets. You calculate the amount of product needed and use the number of packets necessary for a spray batch. Simply drop the unopened packet into the spray mix water and it dissolves. As the packet dissolves, the pesticide is released into the spray mix. Enclosed cabs provide protection for sprays and dusts. However, be very careful so you don't contaminate the inside of the cab. Too often, applicators climb into the cab with contaminated clothing and gloves. This contaminates the cab and it is never clean again. If you use an enclosed cab, fit the unit with a toolbox where you can place your contaminated PPE before entering the clean cab. It's also wise to use soap and water on your hands and face prior to climbing aboard. A mixed load containment pad protects the environment from accidental spills, leaks, and overflows. It also captures equipment rinse water. Typically, the containment pads are constructed with impermeable material like sealed concrete, synthetic liners, or glazed ceramic tile. There's no drain unless the drain leads directly to a holding tank. The pump is used to recover the rinse water or any spilled materials. This material is then placed in holding tanks for later use or disposal. This photo shows a brightly painted containment pad that indicates where the equipment should be parked. Portable mixed load containment pads are also available. Okay, let's shift to looking at some different types of application equipment and their major components. We won't cover all the different types, such as specialty equipment used for termite seed treatment and stored grain. If we look at turf, ornamental, forestry, and agricultural applications, the hydraulic sprayer is the primary piece of liquid spray application equipment. Hydraulic sprayers range in size from handheld and backpacks to small, medium, and large power sprayers. Air blast sprayers apply liquids by using air as the carrier to move the spray droplets into tree and vine canopies. Sprayers need a tank that is large enough to do the job so you don't have to go back and refill time and time again. The tank material must be non-corrosive. Some labels actually have precautions regarding certain tank materials, like poly or galvanized steel. Make sure the tank can be accessed from top and bottom for filling and cleaning. All tanks need some type of agitation unit. As mentioned in the formulation module, most formulations require constant agitation to keep the spray solution well mixed and to prevent settling. The nozzle largely determines the amount of product that's applied in the droplet size classification produced. In addition, the nozzle determines the pattern. Different patterns like flat fan, hollow cone, or solid cone are used to target different pests. Back to drift again. If you want to use a low drift application, select a coarse or medium spray. Nozzles and pressure determine droplet size. Nozzles come in different types and prices. As you would expect, the cheaper the nozzle, the faster the wear. If you use formulations that are abrasive, like wettable powders, dry flowables, and water dispersible granules, they cause brass and aluminum nozzles to wear very quickly. So buying cheap can become an expensive investment since you have to keep replacing nozzles. Plastic or nylon nozzles wear rapidly with emulsifiable concentrates. The best all-around nozzles that last fairly long are hardened stainless steel. However, if you can get over the sticker shock of ceramics, they may be the best nozzles since they last for quite a long time. Regardless of the nozzle type you use, make sure each nozzle is delivering an appropriate volume and spray pattern. Get a copy of the manufacturer nozzle guide booklet and refer to it each time you calibrate your sprayer. If a nozzle is not performing to the standards in the nozzle booklet, replace the nozzle. If more than a single nozzle is worn, replace all the nozzles on the spray boom. Granular applicators are used for band and broadcast applications. Their function is fairly basic and the output and coverage is regulated by the application speed, the size of the gate opening, the granule size, shape, and density, as well as the terrain and weather conditions. Granular applicators rely on two methods of delivery. One method is the rotary spreader that uses a spinning disc or fan. With this type of delivery system, the heaviest granules are thrown the farthest. A drop spreader uses gravity to drop the material from the hopper to the ground. Drop spreaders deliver a much more precise application. With the wide variety of pesticides and the diversity of places where they are applied, there are many other unique types of application equipment. Rubs and dipping vats are used for livestock and pest control. Bait dispensers are used in and around buildings for cockroaches, rodents, flies, and the list goes on and on. Foggers are used for mosquito and biting fly control. There are several different types of dusters, but most are used in structures. Chemigation is a system that injects the pesticide directly into an irrigation system and is used primarily in agriculture and turf. Calibration is the basis for accurate delivery of the appropriate product rate to the application site. Calibration is the process used to determine the amount of product that is applied per area. Again, the volume of product per area. So to calibrate, you must be able to measure the amount of spray delivered. The first box is 1,000 square feet, and if we applied 13 ounces to that area, the sprayer or granular applicator is calibrated at 13 ounces per 1,000 square feet. In turf and ornamentals and pest control in and around buildings, labels are used based on a 100 square foot or 1,000 square foot basis, so we calibrate using units that are similar to the label. So to calibrate a piece of equipment, measure and mark an area that is 1,000 square feet. Apply to that 1,000 square foot area and measure the amount applied. That is all there is to calibration. The second example illustrates applying to a full acre and measuring the volume applied, 18 gallons per acre. Or you can take a smaller area, say 1/100th of an acre, find the amount applied to it, then simply multiply by 100 to convert to an acre. Because it's easier and more convenient to apply to a smaller area, many people use a smaller area and then convert their numbers to an acre basis. So the basis of calibration is determining application rate. Application rate is a function of sprayer output and sprayer speed. Sprayer output is simply the amount delivered over time. It is controlled by nozzle size and pressure. Sprayer speed determines area over time. So if we measure an area and time how long it takes to cover that area, we know one factor. Then, if we collect spray for the same amount of time it took to cover the area, we know output. You have determined output per area, and that's calibration. It may be easier to do calibration with pencil and paper. Note the area covered for a single nozzle, for example, 100 feet by 1.6 feet. Time how long it takes to cover 100 feet and collect nozzle output for that period of time so you have output and area. The equipment calibration is done. There are many methods that can be used for calibration, and there are different math formulas depending on the type of equipment you use. To calibrate, you need some gadgets. You need a measuring tape and markers for measuring the area of your calibration trial. If you're using granular application equipment, you need a scale to measure what you collect, and you may need a tarp to collect the material. If you're using a sprayer, you need a graduated measuring container to collect the nozzle output. Let's look at the basic steps to calibrate a sprayer. First, measure and mark your calibration area. Next, fill the sprayer to at least half full. Time how long it takes you to cover the calibration area using the same techniques as when you would spray the product. For that same length of time that it took to cover the application area, collect the spray from a nozzle. Multiply by the number of nozzles on the boom. Measure the spray width of your boom and multiply by the calibration course. You're done. You have determined the amount of spray delivered to a known area. Here's an example of a math formula that might be used to calibrate a boom sprayer on an acre basis. You don't need to memorize this formula, but let's look at it. GPA is gallons per acre. That is the calibrated delivery rate this formula determines. GPM is the gallon per minute output of the nozzles, so we measure the output of the nozzle over time. Miles per hour tells us how far the sprayer moves over time. Nozzle spacing in inches tells us the width of the application. Width times miles gives us the area. 5,940 is a mathematical constant that converts the many units like minutes, hours, inches, and miles into a single number. This formulation simply measures output and area and is one method of calibration. It is critical when you use a formula to make certain you measure using the appropriate units. If the formula is in gallons per minute, make sure the number you measure is in gallons per minute. Because if you used ounces per minute in the formula, your calibration would be off by a factor of 128. Calibrate your sprayer using the area basis unit found on the label. Some labels have product rates per acre, others 100 or 1,000 square feet. For best accuracy, measure out the full area noted on the label. If you use a smaller area and then convert the numbers, you lose some accuracy. Calibration allows you to determine the delivery rate per area, and if necessary, you can adjust your application equipment to meet label requirements. If you calibrated your sprayer and it delivered 18 gallons per acre, but the label required a minimum of 20 gallons per acre, you need to adjust the equipment. After adjusting the equipment, it is important to recalibrate to make sure you meet the minimum label requirement. Equipment that is properly calibrated delivers the proper rate to the target pest. If equipment is not calibrated correctly, you may apply too much or too little. Either way, you waste money by using too much or not achieving control with the money invested. Remember our discussion about product registration. To achieve pest management with no unreasonable effects on humans and the environment, you must apply the appropriate amount. If you apply more, harm may occur, as well as illegal residues. Calibrate the equipment anytime you change equipment setup, such as changing nozzles, pump pressure, or boom height. If you change products, calibrate your equipment. At least once a season, probably more often, check equipment for wear. A worn nozzle delivers more output. If you're concerned about application costs or efficacy, accurate calibration is critical. Can you imagine the amount of money wasted if you misapplied along a railroad for 200 miles? Any error in calibration hits the pocketbook, and when you don't apply a sufficient rate to control pests, you've wasted time and money. Yep, you guessed it. You need to have some basic math skills to be a certified pesticide applicator. You must be able to multiply and divide. You also need to know how to multiply fractions and do ratio calculations so you can calculate the correct amount of product and spray mix. Some spray guides and reference materials have formulas to assist with equipment calibration and application. Make sure your units and calculations are accurate when using formulas. It's necessary to be able to calculate areas of basic shapes, like rectangles, circles, and triangles. Most people know how to calculate the area of a rectangle. Multiply the length times the width. For this example, multiply 125 feet by 40 feet, and you get 5,000 square feet. The area of a circle relies on two math factors: the radius of the circle, which is half the diameter, and pi, which is the math constant 3.14. The area of a circle formulation is the radius squared times pi 3.14. So 35 times 35 times 3.14 equals 3,846.5 square feet. Remember, don't confuse diameter with radius, which is half the diameter. Now, to calculate the area of a triangle, multiply the base times the height divided by 2. In this example, the base is 20 feet and the height is 30 feet. Multiplied, they equals 600. Divide 600 by 2 and the area equals 30 square feet. Unfortunately, the real world is not all boxes, circles, and triangles. You'll need to calculate irregularly shaped areas. The area can be calculated by overlaying basic shapes onto your application site. This gives you a fairly close estimate of its area. Calculate each subunit area and add them all together to reach a total area for the application site. This illustration has one triangle and two rectangles. The triangle is base times height divided by 2, or 25 times 25 divided by 2. The first rectangle is 42 by 30, so multiply those two numbers together. The last rectangle is 31 times 33, so the total area is 2,595 square feet. Now, if you're working in turf and the label directions are per 1,000 square feet, you can determine how much spray is needed based on the 2,595 square feet total. However, if the label directions are based on acres, you must convert the square feet total to a per acre basis. Divide 2,595 square feet by the area of an acre, which is 43,560 square feet. The 2,595 foot application area is 0.06 acres. The calibrated delivery rate must be determined before you can do the calculations to determine the amount of product you need for a job, and the amount of spray mix needed. Read the label for any spray mix volume requirements and for the product rate. If you are uncertain with the calibration or any calculations, ask someone to double check your math. Errors are dollars. As mentioned earlier, it's easy to do all your pesticide math if you calibrate your sprayer using the same units as listed in the use directions for the product you're handling. Some labels state applications per acre, others per 1,000 square feet, or even smaller units. Liquid product rates are listed in gallons, quarts, pints, and ounces. Dry products are listed in ounces or pounds. If you're following a recommendation, such as from an extension bulletin, the rate is usually listed in the form of pounds of active ingredient, not product. You have to convert active ingredient rates to product rates once you have selected the product. Make sure you understand the units you're using. If you need to change units, make sure you use the correct conversion factor. Okay, let's do a basic pesticide math problem. We are going to treat a turf area that is 40 feet by 300 feet for a weed infestation. The label application rate is 4 ounces of product per 1,000 square feet. How many ounces of product do we need to treat the area? First, determine the area to be treated. 40 times 300 equals 12,000 square feet. Most of you can do the rest in your head, but let's look at how the math is actually done. Next, determine how many 1,000 square foot units there are in 12,000. So we take 12,000 and divide by 1,000 and get 12 units. If the label calls for 4 ounces per 1 unit of 1,000 square feet, and we have 12 units, multiply 4 times 12. We need 48 ounces of product to treat the area. Many times you need more than a tank load of spray, and you have to calculate how much product you need per tank load. In order to do this, you first have to determine how much area one tank load covers. Let's look at this example. Our sprayer is calibrated at 20 gallons per acre. The tank holds 300 gallons. The label rate is 2 quarts per acre. How much product goes into a full tank? To determine area treated, take the tank size in gallons, 300, and divide by the sprayer delivery rate of 20 gallons per acre, so the tank covers 15 acres. Now determine the amount of product needed. 15 acres times 2 quarts per acre equals 30 quarts. We'd usually convert this to gallons since it's a larger volume. To convert quarts to gallons, divide 30 quarts by 4 quarts per gallon. So it takes 7.5 gallons of product to make up 300 gallons of spray. This is a very common pesticide math problem. Cross multiplication is another basic math skill for determining amount of surfactant or other spray additives, or for small volume applications by calculating equivalent ratios. If the label states a basic ratio, such as use 1.5 quarts surfactant per 100 gallons of spray, you can use cross multiplication to find the equivalent ratio for a larger or smaller volume. To set up the math problem, state the ratio you know on the left side of the equal sign. On the right side of the equal sign, put the known value on the bottom and the unknown value on the top with an X or question mark. It is critical that the units on the right and left must be in the same position in the ratio. So if gallons is on the bottom on the right of the equal sign, it must be on the bottom position on the left. Otherwise, switch the figures on the left to match the right. In this example, gallons are on the bottom of both sides, and quarts are on the top of both sides. Once you have equivalent units on both sides, you can do cross multiplication. Take the number on the lower right and multiply it by the number on the upper left, in this case 45 times 1.5. Then divide the results by the number on the lower left, in this case 100. That's it. Make certain that your answer looks appropriate. 45 gallons is nearly half of 100 gallons, so the number of quarts should be about half of 1.5, and 0.675 quarts is just under half of 1.5 quarts. Always make sure the answer makes sense. Human exposure, plant damage, and impacts on the environment occur too frequently from poorly planned applications that result in drift. Let's finish up this module by revisiting drift, since it's an important issue for application planning. Labels provide warnings about products that have concern for volatility. Read the label. Some labels list specific restrictions on application equipment. Orchard sprayers require that nozzles be directed at the target and that only one side of the sprayer can operate on the outer 2 tree rows. Other labels require specific volumes of spray be applied, so calibration is critical. Many newer labels state a specific droplet size classification that must be used, and some recommend use of new low drift technologies. Today there are labels that specify that is a buffer or no spray zone adjacent to an application. Labels may have requirements for downwind considerations and may limit applications during certain high or low wind speeds. Many labels prohibit the application of pesticides during a temperature inversion. In your application planning, it is your responsibility to minimize drift. When planning, your equipment setup and tank mix solution play an important role. The type of nozzle is key. Some nozzles provide for low drift application. Nozzle size and pressure determine droplet size and the concern for spray drift. Sprayer speed controls how stable the boom is during an application. Bouncing booms make for driftable droplets. Boom height in relation to the crop plays an important role. Know how to plan your application to compensate for these concerns or to change your setup. Some drift adjuvants on the market work well, others do not. Before and during an application, monitor weather conditions, wind direction, speed, temperature inversions, temperature, and humidity. If you're concerned with drift and need to minimize drift, use low drift nozzle technology. Make sure you understand the technical requirements for low drift technology because some of the new nozzles only provide effective pest control and low drift at higher pressures. When using regular nozzles, use nozzles with a larger nozzle orifice to get larger droplets. Again, read the label since it may have specific nozzle restrictions. When discussing drift, it is important to consider the effects of pressure. Since both pressure and the nozzle orifice determine sprayer output and droplet size, one might consider making changes with pressure to change output. However, to double your sprayer output, you actually have to increase the pressure 4 times. When you make large changes in pressure, you affect droplet size and can increase drift potential. However, when you change nozzles, you get a 1-to-1 correlation. As you double the nozzle size, you double the output. So remember, pressure takes a 4-fold increase to double output, while to double output by nozzles, double the size of the nozzle size. That's why it's recommended to manage drift with changes in nozzles, not pressure. Application height affects drift because of the time it takes for the droplets to fall. If you're near sensitive sites and applying higher in the air, don't apply right up to the edge of the field. Or when near the edge of a field, use another application method that applies closer to the target. There are several different drift reduction products on the market. They change the viscosity of the spray mix so it breaks into larger droplets. Some products work well and some don't. So evaluate these products before you rely on them for drift management. When planning an application, there are numerous considerations. Make sure the product is labeled for use on the target site. Be confident that it controls the pest. Select the best product for formulation based on safety, equipment concerns, and costs. Use precautions to reduce your exposure. Consider appropriate PPE and closed systems for mixing and loading. Select equipment that is suitable for the job and that can handle the formulated product. Make certain it's set up and functioning properly. Make sure it's calibrated for the product. Assess environmental considerations and put in place appropriate precautions. Calibration is essential to effective pest control. Whether it is a large or small application, spray, mist, dust, or granule, calibrate for the product you plan to use. Make sure you are delivering the correct dose to the target site. Keep an eye open at all times and be a responsible applicator. Question 1. Which of the following would contribute to minimizing drift potential? 1. Small nozzle orifice. 2. 4 mile per hour wind speed. 3. High spray pressure. 4. 1.5 foot boom height. Select the correct answer. A. 1 and 3 only. B. 2 and 4 only. C. 1 and 4 only. D. 3 and 2 only. Correct answer B. A 4 mile per hour wind speed is ideal for spraying and allows the applicator to assess wind direction, which is critical for managing drift. Spraying under high wind conditions as well as very still conditions must both be avoided. Now you just have to manage the droplet size and make your application as close to the target as possible. Small nozzles make small droplets as does high pressure, so both would increase drift. Typically, to manage drift, you select nozzles with a larger orifice and use lower pressures. Increasing boom height would not help because the higher the nozzles are from the ground, the farther the spray can drift. Question 2. Which type of application would you perform to treat a basement where there is evidence of a cockroach infestation? A. Broadcast application. B. Dip. C. Basal application. D, crack and crevice application. The correct answer is D, crack and crevice application. Question 3. You need to treat a round golf green. The diameter of the golf green is 100 feet. The label rate is 3 ounces of product to 1,000 square feet. How much product do you need to treat the green? A, 23.5 ounces, B, 47 ounces, C, 94.2 ounces, D, 62.7 ounces. Remember, the area of a circle is 3.14 times the radius squared. Take a minute and try this calculation. If the diameter is 100, then the radius is 50. 50 times 50 times 3.14 equals 7,850 square feet. Divide 7,850 by 1,000 to find out how many units you have. There are 7.85 units of 1,000 square feet each in the circle. So 7.85 times 3 ounces equals 23.5 ounces needed to treat that circle. The correct answer is A. Special thanks to the Washington State University Extension, Carol Ramsey Black, Carrie Foss, Rebecca Hines, and Brett Johnson. Narrator, Adam Ziada, Pesticide Safety Education Program, Ohio State University Extension.